Welcome to Rayat Shikshan Sanstha's Rayat Online School Education for Junior College. Subject is Physics. Myself, Jadhav Vian from R.R. Shinde Junior College, Hadapsar, Pune. In today's lecture, we are going to discuss light-related concepts. Those are reflection of light and refraction of light. Before we start today's lecture, we have to know light is a form of energy which helps us to see the object. This is due to a reflection of light. That point, reflection of light, you have already studied in 8th standard. Here I show one image. In that image, torch giving a light in the form of rays. That rays incident on a plane or a smooth surface and get reflected, and we can see that the light coming here. That means the process through which light rays falling on the surface on an object are sent back is called reflection of light. We have also studied the laws related to reflection of light. We called as laws of reflection. In this image, here the PQ is a plane mirror. And on that plane mirror, the incident ray incident at a point O, where N is the normal to the plane surface or a mirror. When the light is incident on a mirror, it get reflected as a reflected ray. These both the rays, incident and reflected, makes an angle. The incident ray makes an angle with normal we called as angle of incidence, whereas the angle of reflection is the angle made by reflected ray with the normal. Now the first law of reflection says that the angle of reflection is equal to angle of incidence, means angle of incidence I is equal to R. This angle are equal. Now the next law says that the incident ray, the reflected ray and the normal lie in the same plane. You can observe in this image incident ray, normal and reflected ray all are lies in a same plane. And the third law says that the incident ray and the reflected ray are on the opposite side of the normal. You can clearly observe that here is a normal, incident ray and reflected ray are opposite to each other or opposite to normal. On the basis of laws of reflection, you also studied the regular reflection of light and irregular reflection of light. In a regular reflection of light, when a light incident on a plane or a smooth surface and then reflected, that reflected ray, we say that regular reflection of light. When these rays, when considered on an irregular shape or a rough surface, then we cannot observe same path of reflected rays. Here in a regular reflection, the incident ray are parallel to each other, means their angle of incidence, that is I1 is equal to I2 is equal to I3. According to the law of reflection, angle of incidence is equal to angle of reflection. When the rays are incident parallelly, then the angle of reflection of that rays are also equal, so that we can write R1 is equal to R2 is equal to R3. And when the reflection of light from the rough surface is called irregular reflection of light. In this, the ray of incident are parallel, but at the incident point, means here we can call it as a point of incidence, the surface is not plane. Because of that, the angle of reflection or a reflected ray are not parallel to each other. That's why here angle of incidence are also not equal, means I1 is not equal to I2 is not equal to I3. Similarly, angle of reflection are also not equal. In both the images, we have to understood that the laws of reflection are followed in both. Okay, but because of the smooth surface and rough surface we get different result. The next point, you also did some activity to understand the concept of reflection of light through kaleidoscope and periscope. The first one is a kaleidoscope. In this application or this device work on the principle of multiple reflection of light. Here, two or more mirrors are inclined to each other. We can see the image inside the kaleidoscope here. Second activity is a periscope. This device is also based on the principle of laws of reflection. In this, mirror or prism is placed at the end of inclined plane at an 45 degree. The light first fall on the top and reflected vertically downward. This light reflect again by second mirror and we can see the image of this object. This device is used in submarines to observe the object. Okay, in next standard, means ninth standard, reflection of light, you have studied that light reflect differently from different surfaces, and the first point of that topic is mirror and types of mirror. So the mirror is scientifically defined as, in scientific language, surface which reflects light and creates clear image is called mirror. The types of mirror, the first mirror was plane mirror. You can observe in this image, or you have this type of mirror in your home also. So I can show some plane mirror images here. In plane mirror we can see clear image when we stand in front of plane mirror. If you consider, instead of this big object, if you consider a point source of light, we get the reflection, and due to that reflection you feel that the object is behind the mirror. You can understand this point through these figures. Here in first diagram, light is falling perpendicular and reflected perpendicularly to the surface of mirror. So the path of incident ray and reflected ray is same. Now in second figure, there is also one plane mirror M1, M2. In front of that plane mirror, we are placing one object O. That object O gives the incident ray and which falls on the plane mirror and gets reflected here, and we can see that object now here. But if we extend these reflected rays in backward direction, we get one point. That point is O1. Here object is O. We are here giving this name is a O1. That is the image of the object O. Why we called this point as an image? Because we appears the rays are coming from this point and we can see the object clearly. So we said point O1 as an image and O as an object. From this we also got one important point. When reflected rays do not actually meet, then the image formed by that object is a virtual image. When the two reflected rays do not meet, then the image formed due to that object is a virtual image. And in last figure you can see we are placing pencil, not placing a point object or point object source here. So we use extended source instead of point source. We get extended image. Here we already discussed that for a plane mirror, that plane mirror gives the clear image. There is no change in its size. Okay. Our next point is a spherical mirror. In spherical mirror, there is a first type of mirror, that is a concave mirror. If the inner surface of the spherical mirror is the reflecting surface, then it is called a concave mirror. Here you can see in this picture the inner surface is a reflecting surface. So this type of mirror we called as concave mirror. Now the next mirror is a convex mirror. If the outer surface of the spherical mirror is the reflecting surface, then it is called a convex mirror. Here the outer surface is reflecting. That's why we called as convex mirror. The next point is terms related to a spherical mirror. First of all, you have to know the point that is the mirror or a spherical mirror are the part of one of the sphere. So the first term in this spherical mirror is a pole. The center of the mirror surface is called its pole. Here the point P we called as a pole. Next, the center of curvature. The center of a sphere of which the mirror is a part is called the center of curvature. Here, center of curvature of the mirror. Now, the sphere or spherical mirror we have considered is a part of one of the sphere, and the center of that sphere is called as the center of curvature of that mirror also. Now the next point is a radius of curvature. The radius of the sphere of which the mirror is a part is called the radius of curvature of the mirror. Now this is a spherical mirror, is a part of this sphere having center C we call as the center of curvature. From this we can draw a radius, and that radius is a radius of curvature of that sphere. Here the CP and CA are the radius of curvatures. The next point is principal axis. The straight line passing through the pole and the center of curvature of the mirror is called the principal axis. Here I can give a name to the principal axis. PM is here. Here the PM is the principal axis. Okay, radius of curvatures are CP and CA. Pole is P, center of curvature denoted by C. Now the next point is principal focus. Incident ray which are parallel to the principal axis of a concave mirror after reflecting the reflection from the mirror meet at a particular point in front of the mirror on the principal axis. This point F is called the principal focus of the concave mirror. So for understanding this point, you have to know the rules which are used for drawing the ray diagram. Or here we can say, or we can see here there is a concave mirror. When the rays are parallel to the principal axis, after reflection they can pass through one of the point which is on the principal axis. That point we called as a focus. Okay, here is a definition of that point, and we have considered the concave mirror. In this image we are also consider the concave mirror. Next, the focal length. The distance F between the pole and the principal focus of the mirror is called the focal length. Here is the focus, and the distance between the pole and principal focus of the mirror is called the focal length. This length is focal length. Okay, now next point is rules to draw a ray diagram, which we already discussed. One of the rule that when the rays incident on mirror, when the rays are parallel to the principal axis, that one is our first rule. Okay, rule number 1. If an incident ray is a parallel to the principal axis, then the reflected ray passes through the principal focus. Here they can show through image the incident ray which is parallel to the principal axis. Here we have to give the direction, because direction are important in this topic. After reflection, the reflected ray passes through one of the point on the principal axis. That point we call a principal focus. We already know that point. Here the rule, what the rule says, when the ray is parallel to the principal axis, they will be reflect from the principal focus. Now the second rule, if an incident ray passes through the principal focus, the mirror, the reflected ray is parallel to the principal axis. If an incident ray passes through the principal focus of the mirror, the reflected ray is parallel to the principal axis. When the incident ray here, this one is a incident ray which will passing through the focus of the mirror. When the ray passes through the focus of the mirror and get reflected, then the reflected ray which is going in parallel direction to the principal axis. And the third one is if an incident ray passes through the center of curvature of the mirror, the reflected ray takes the same path back. When the incident ray passes through the center of curvature, then the reflected ray has the same path which incident ray have. Here, image formed by the concave mirror is our next point. Now, we have to consider one object. Here is the concave mirror and this one is a center of curvature focus. Okay. Now, we are placing the object AB in between center of curvature and focus. We are taking two rays from the object. One of the ray is passing parallelly, incident ray, passing parallelly to the principal axis, and after reflection, when the ray is parallel to the principal axis, that ray will get reflected through the principal focus. Okay. Now the next ray is passing from focus. If the ray is passing from the focus, then it get reflected and the path of that ray is parallel to the principal axis. We already discussed this rule in a previous slide. Okay, when this reflected ray intersect somewhere, means this point at A dash, we get the image of object AB, and that image we called as A dash B dash. Now we change the place of object. Now here is the center of curvature and this one is a focus. We are placing the object here. Now object is in between pole and the principal focus of mirror. Again we are considering two rays. The first ray which is passing from the center of curvature, and when the ray passing from the center of curvature, it will get reflected through same path. Third rule we have already seen. Now the second ray is passing from point A, and which is parallel to the principal axis. When the ray is parallel to the principal axis, it will get reflected and go through the principal focus. Now these two reflected rays, means if you consider that one is this one is also reflected and red color is also reflected. They are not intersecting on the left side of the mirror. So we have to extend that rays in backward direction, so they intersect at a point A dash, and we get the image of the object AB, which is A dash B dash. These are the examples of image formed by the concave mirror, which is depend on the position of the object. We get the image when the object is placed somewhere on the principal axis. Now there is a table which will give you the idea when the object position is described and you get the position of image. First one is between pole and focus, which we have already discussed. Behind the mirror, position of image is behind the mirror. Now nature of the image is erect and virtual. Size of the image is magnified. At the focus, position of image is at infinity. Nature of image is inverted, real. Size of the image very large. Between focus and the center of curvature, this example is also upon we have discussed. Beyond the center of curvature, inverted and real, magnified. Now next is at the center of the curvature. At the center of curvature, inverted, real, same as the object. This point is also important, at the center of curvature. Beyond the center of curvature, between the center of curvature and focus, inverted, real and diminished. At a very large distance, or we can call as at infinity, then the position of image is at focus. That image is inverted and real. Size of the image is a point image. Okay, now the next mirror is a convex mirror, image formed by the convex mirror. Here we considering the one convex mirror. Object is placed here in front of the convex mirror. The name of object or size of object can be given as AB. Now we are considering again two rays. The first ray, which is parallel to the principal axis. When the ray is parallel to the principal axis, that ray will get reflected, and here it cannot pass through the focus, means the convex mirror focus is not on the left hand side, because this is spherical. This mirror is somewhere part of the sphere, and the center of curvature of that sphere becomes here, so the focus is now at this point. So we extend that reflected ray which will pass through the focus. Now the next ray we are considering is from the center of curvature. Okay, and we get the reflection from the same path. These two reflected back-sided extended rays meet at a point A dash, and we get the image A dash B dash of object AB. This is image formed by the convex mirror. Now the next important point is a Cartesian sign convention. This Cartesian sign convention we are used to solve the problems and also in some equations also. Now this one is a concave mirror. This is the pole of that mirror. We're taking distance on left side as a negative and distance on right hand side are taken as a positive. Distance in upward direction is positive, distance in downward direction is a negative. That distance is measured from the pole. Okay, these Cartesian sign conventions are also important in our 11th standard. Next point is mirror formula. This mirror formula is a relation between object distance u, image distance v and focal length f is known as mirror formula. This relation gives us the value of distance by using correct value of distance using Cartesian sign convention. We can give this formula by 1 upon v plus 1 upon u is equal to 1 upon f. That can be used to solve the problems. This formula is valid for all spherical mirrors. Now the next point is magnification due to spherical mirrors. The magnification due to spherical mirror is given by the ratio of the height of the image h2 to the height of object h1. That magnification denoted by capital M. This is the formula for magnification, height of object upon height of image upon height of object, h2 by h1. We can write this equation by using object distance and image distance as m magnification is equal to minus V upon U. Now move towards the next point, that is our chapter in 10th standard, refraction of light. The refraction of light, we can say light changes its direction when going from one transparent medium to another transparent medium. This is called refraction of light. We also discuss the laws of refraction. The first law says that the incident ray and the refracted ray at the point of incidence n are on the opposite sides of the normal to the surface of the slab at that point, that is CD. Here is the normal, this one is incident ray, n is a point of incidence, and that is refracted ray. The incident ray and refracted ray are opposite to the normal and also to the surface. And the three, incident ray, refracted ray and the normal, are in the same plane. We can clearly see that incident ray, normal and refracted ray are in same plane. Now the second law of refraction says that for a given pair of media, here air and glass, the ratio of sin I to sin R is a constant. Here I is the angle of incidence and R is the angle of refraction. We can say this law as a Snell's law also, that is sin I upon sin R is equal to constant, or we can denote that constant by small n. Now the next point is refractive index. When light travels from one medium to other medium, the direction of light changes due to refractive index of that medium. That refractive index depends on the velocity of light in the medium. Here we are considering two mediums. The first medium is air and the second medium is glass. Now incident ray of light is in a first medium, air medium. After that is refracted, then it passes through glass. The velocity of that medium in air is V1 and that of in glass is V2. Now the refractive index is given by refractive index of second medium with respect to first is equal to velocity of light in medium first, that is V1, to the velocity of light in medium second, that is V2. Here we can write refractive index of a second medium with respect to first is equal to V1 by V2. Similarly, you can write refractive index of first with respect to second is equal to V2 by V1. Refractive index of first with respect to second. Now move towards the next point, that is the refraction of light in a different medium. Here we consider the medium when light passes from rarer to denser or denser to rarer. What happened to the refracted ray? Now first one is when a light ray passes from a rarer medium to a denser medium, it bends towards the normal. This one is a rarer medium, this one denser medium. When light passes from rarer to denser, then that ray or a refracted ray bend towards the normal. If the light passes from denser to rarer, here when a light ray passes from a denser medium to a rarer medium, it bends away from the normal. This one is a denser medium, light passing from a denser medium to rarer medium, that ray will bend away from the normal. And last one, when light ray is incident normally at the boundary between two media, it does not change its direction and hence does not get refracted. When light incident normally at a boundary between the two medium, then that ray will not bend towards or away. The direction of that ray is the same as incident on the boundary of that surface. Now the next point is a dispersion of light. Sir Isaac Newton was the first person to use the glass prism to obtain the spectrum. Here we can get the process of a separation of light into its component color while passing through a medium is called the dispersion of light. When white light is incident on the prism, we get 7 constant colors or the spectrum of 7 color. Next point is partial and total internal reflection. Here light is passing from, we can observe by arrow that light is passing from denser medium to rarer medium. Why I am calling it denser? Because water is denser than air. Now light is incident at this point when we can draw a normal, and that angle is called angle of incidence. After refraction, that is light traveling from denser to rarer, then the refracted ray bends away from the normal. Now angle of incidence and angle of refraction as given by, that is angle of refraction is greater than angle of incidence, because that refracted ray bends away from the normal. As you increase the angle of incidence in the second case, you got the angle of refraction are also increased. At the particular point of angle of incidence, the refracted ray makes an angle 90 degree with the normal. That value of incident angle is called as a critical angle. This value of incident angle we can call as a critical angle. Now in the next case, the angle of incidence is greater than that critical angle. Now you can observe that a refracted ray makes angle more than 90 degree with the normal, and we cannot call that ray as a refracted ray because this ray is written in the same medium. We call as a reflected ray. Now all the light is get reflected in a denser medium. This concept is known as total internal reflection. And the last point from that topic is a rainbow production. Rainbow is the combination of all the effect, that is natural process. It is combined effect of a dispersion, refraction and total internal reflection. You can observe all these three in this rainbow.